We will learn about the measure of location here, and one of the measures is called G-score, and we will learn how to calculate it on a data. I've taken a very simple data which has 5 values, 1, 2, 3, 4, 5, easier to compute. First step is we'll calculate what is the mean of these 5 values, which is your average. And that's 3. Now the next step is to calculate relative to this mean, where are each of these values in the data set lie. The values which all are less than the mean are to the left of the mean, and the values which are higher than mean are to the right of the mean. So let's calculate these. Is equal to x value minus the mean. We want to keep the reference to mean constant, so that's why we have applied this dollar sign. So relatively, so we can say the relative location of 1 from mean is -2. So now we know when we see these deviation values, we know that this is these many units to the left or to the right of the mean. Since the sum total of these deviations from mean equals to 0, let's check that. We are not able to calculate on an average how much deviation has happened. So 0 here as the total deviation as 0 is a misnomer. So what we do is to remove these negative numbers, we convert it into squares. So we just find the square value of the deviation. And the sum of the square of the deviation is easily calculatable using the formula sum. So the total variance of the data is 10 units. Now this total variance of 10 units is spread over these 5 values. So you're going to average it. Is equal to total variance divided by count of number of values that we have. So on an average, we see a variance of 2 units, which is called as variance. Since we have squared the deviations, so this is in the square scale, we want to bring it back to the original scale. So we will take the square root, power 0.5, that is square root. So it turns out to be 1.414, and it is called as standard deviation. Now we will need the standard deviation to calculate the relative value with respect to mean in multiples of the standard deviation. So we are rescaling this data to develop a very useful measure of deviation. So what we do is x minus mu divided by sigma. That tells us that 1 is minus 1.414 standard deviations away from the mean tree. Can extend this formula to the other cells also. And we of course know that 3 is 0 standard deviations away from 3, that is the mean. So this scale converts the deviations in the data in multiples of standard deviations. So this is how we get the Z-score, and Z-score forms the foundational concept in the inferential statistics.